Good morning, class. We are looking at statistics, practice test number 1, module 1, covering chapters 1, 2, 3. Here's chapter 1, Introduction to Statistics. Now, when you take the exam, before starting the exam, please read the following pledge. I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam or any other exam. Unauthorized actions include, but are not limited to, the use of notes, text, graphing calculators, search engines, PowerPoints, AI, or any other resource not explicitly allowed. You may use a graphing calculator. However, graphing calculator cannot be just the source of the solution. You have to justify your answers. That's the idea behind that. So having said that, let's move on. This section basically consists of definitions. There's really not much to that. So elementary statistics, chapter 1, introduction to statistics. Before I even go over this question, what is a statistics? I want to give you the definition. Statistics, the science of planning studies and experiments, obtaining data and organizing, summarizing, presenting, analyzing, and interpreting those data, and then drawing conclusion based on them with some measure of confidence. Statistics also aims to discover sources of variability. The process involved in conducting a statistical study consists of prepare, analyze, and conclude. So that's the idea behind statistics. True or false? The value of variance and standard deviation is never negative. That's a true statement. These are absolute quantities that is a measure of variation of all values from the mean. It can be zero. So what do we mean by that? All we have to do, look at the formulas. Remember, you have access to formulas. For the population, we use sigma squared. Population variance, sigma squared, is summation of x minus mu, quantity squared over n. Mu is the population mean. And that is called the variance. You take a root, becomes the standard deviation. As you can see, x minus mu, whether it's positive or not, makes no difference. When you square it, is positive, and so is n, the number of data. As far as the sample is concerned, we use s squared for variance instead of sigma squared. In other words, we use Greek letters for population. So s squared is summation of x minus x bar quantity squared over n minus 1. And that's the difference. Divided by n, this one is n minus 1. Capital N represents the population size, lowercase n sample size. Simplified version of that would be n summation of x squared minus summation of x quantity squared over n times n minus 1. And this can be put into a calculator, and the answer for a few pieces of data, you can do it by hand. Otherwise, you can use a calculator. And of course, S is the same thing, take a root. Okay. And obviously, they are non-negative. Can they be zero? Yes. What kind of variable weights of bears is quantitative or qualitative? So let's remind everybody. Quantitative and qualitative variables are two types of variables usually used in data analysis and statistics. Quantitative variables, also known as numerical variables, represents measurements or quantities that can be expressed numerically. So this is a quantitative variable. Weights of bears give numbers that represent counts or measurements. What about gender of bears? What kind of variable is that? Qualitative variables, also known as categorical variables, represent characteristics or qualities that do not have a numerical value. These variables are typically divided into categories or groups. Examples of qualitative variables include gender, marital status, or types of cars. In summary, quantitative variables involve numerical measurements or quantities, while qualitative variables represent non-numerical characteristics or category. So in this case, we are dealing with the qualitative because gender of bears is distinguished by non-numeric characteristics. So pretty straightforward. Define population and sample in statistics. Population is the complete collection of all elements, scores, people, measurement, etc. to be studied. Sample, a sub-collection, portion, or fraction of elements drawn from the population. So let's look at more precise definition. Well, population. The population refers to the entire set of individuals, objects, or events that possess certain characteristics of interest and are the subject of statistical investigation. However, populations can be large and sometimes impossible to study in their entirety due to practical limitations. Sample. A sample is a subset or a smaller representative group selected from the population. It is a portion of the population that is chosen to represent the whole. In summary, the population refers to the entire group of interest, while a sample is a smaller subset selected from the population for analysis. Statistical analyses are typically conducted on samples to draw a conclusion about the population from which they were drawn. In short, population refers to all somehow. Sample refers to a portion, a fraction. Normally, we don't have access to population. There are limitations. And we use sample to make a decision about the population. That's the synopsis of that. The value of the middle term in a ranked data set is called the median. Given any data, how do you find the mode? Mode is the value that appears with the greatest frequency among the data. A data set that can have a one, more than one, or no mode when all numbers appear with equal frequency. True or false? The number of chairs is considered to be a continuous variable. That's a false statement. The number of chairs is not continuous. We cannot have 1/4 of a chair. Well, let's discuss that further. Discrete. Data result when the number of possible values is either a finite number or a countable number of possible values 0, 1, 2, 3, etc. Examples: number of students in a class, number of cars in a parking lot, and so on. Continuous. Data that can take any value in an interval. Data result from infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps, interruption, or jumps. The weight or height of a person would be an example. What is a Pareto chart? What does each axis represent? A Pareto chart, similar to histogram and named after Vilfredo Pareto, is a type of bar chart used to display categorical, also known as qualitative data. The categories are shown on the x-axis, the horizontal axis, and their frequencies or relative frequencies are along the y-axis, okay? The bars are arranged from highest to lowest frequency, in other words, in descending order, making it easy to identify the categories that occur most often or have the greatest impact. Since I mentioned histogram, let's discuss that also. So this is an example of a Pareto chart. You see bars, and it goes from the largest to the smallest. A histogram is a type of graph used to display the distribution of quantitative data. So this is for qualitative. This is for quantitative. That's the difference. The x-axis represents intervals or bins of numerical values. And the y-axis represents the frequency of observation within each interval. Unlike a Pareto chart, the bars in a histogram are adjacent because the data are continuous or ordered numerical values. So they may or may not be adjacent for Pareto chart, but for histogram, they must be. And as you can see along the x-axis, we have intervals of numerical intervals. Define a parameter and a statistic. A numerical measurement describing some characteristic of a population is called a parameter. A numerical measurement describing some characteristic of a sample is called statistic. Example, the average height of all, and all is the key for the population and therefore a parameter. All adult women in the world is a parameter, whereas the average height of 100 women selected from a specific city is a statistic. So we can distinguish between the two. Define random sample and simple random sample, SRS sometimes it's called. Random sample. Members of the population are selected in such a way that each individual member has an equal chance of being selected, and that's extremely important in statistics. Simple random sample of size n. Subjects selected in such a way that every possible sample of the same size n has the same chance of being chosen. So this is for an individual, this is for a group of size n. RS, random sample. A researcher randomly selects patients from a hospital to participate in a study. While each patient has a chance of being chosen, there is not necessarily an equal chance for every possible group of patients to be selected. So that's random sample. SRS, simple random sample. A company with 250 employees selects 25 employees by assigning each employee a number and then randomly selecting numbers from a hat or using a random number generator. Every possible group of 25 employees, and that's a key, every possible group of 25 employees has an equal chance of being selected. That is simple random sample. Define the following types of sampling: systematic, convenience, stratified, and cluster. Systematic sampling. Select some starting point, randomly of course, and then select every k element in the population. Example, in a population of 50,000 people, a statistician selects every 100 person for sampling. Convenience sampling. Use results that are easy to get. Example, standing at a mall or a grocery store and asking people to answer questions would be an example of a convenience sample. Or you may randomly ask your fellow students about some subject that is convenience sample. Okay, we're going to continue with the same question, of course. We are not done. Stratified sampling. Divide the population into homogeneous. The subjects within the same subgroup must be similar and share the same characteristics. That's the meaning of homogeneous group. Subgroups are called strata, and then obtaining a simple random sample from each subgroup. Cluster sampling. Divide the population into sections or clusters, non-homogeneous subgroups. In other words, this one, each group is the same. This one, groups are not the same. Then randomly select some of those clusters and choose all the members from those selected clusters. So this might actually explain it pretty good if you look at this justification. Stratified sampling means you have a bunch of groups. As you can see, within each group, they are similar. And you randomly pick some from each group. Whereas here, the groups is a cluster. And so every group can be a representative, and you may pick one or more than. Example, stratified sampling. A researcher wants to survey students about their study habits. They divide the student population into strata based on grade level, freshman, sophomore, junior, senior, and then randomly select a sample of students from each grade level. So we pick a few from each group. That's stratified. On the other hand, cluster sampling. A school district wants to assess the reading level of students. They randomly select a few schools, clusters, and then assess the reading levels of all students in those schools. So that's an example of a cluster sample. What are different levels of measurement of data? Give examples. Starting with nominal. Nominal level of measurement is described by the data that consists of names, labels, or categories only, and the data cannot be arranged in some order, such as low to high. In essence, it's a qualitative. Example. Survey responses of yes, no, undecided. Eye color of blue, brown, black, other. Political party, Democrat, Republican, Independent, and other. So those are examples of nominal. What about ordinal? Ordinal level of measurement involves data that can be arranged in some order, but differences obtained by subtraction, for example, between data values either cannot be determined or are meaningless. Here's examples. Ranks of colleges. Ranks can be first, second, third, and so on, which determines an ordering. Assessing grades of A, B, C, D, or F. These grades can be arranged in order, but we can't determine difference between the grades. Going to continue on that thoughts. The next one is the interval. Interval level of measurement involves data that can be arranged in order, and the differences between data values can be found and are meaningful. However, there is no natural zero starting point at which none of the quantity is present. A value of zero doesn't mean the absence of quantity. Arithmetic operations such as addition and subtraction can be performed on values of the variable. Examples. Temperature of 98.2 degrees Fahrenheit and 98.6 degrees Fahrenheit. Years 1000, 2000, 1776, 1492. pH, SAT scores. So their difference has a meaning, but there is no natural zero. Ratio level of measurement data can be arranged in order. Differences can be found and are meaningful, and there is a natural zero. So we add this component to intervals becomes ratio. By natural zero, we mean starting point, where zero indicates none of the quantity is present. Differences and ratios are both meaningful. Arithmetic operations such as multiplication and division can be performed on the values of the variable. So, examples. Distances traveled. 0 kilometer represents no distance traveled, and 400 kilometers is twice as far as 200 kilometers. Prices of books. $0 does represent no cost, and a $100 book does cost twice as much as a $50. So that makes it, I think, sort of easy to understand and distinguish among those. What's the difference between an observational study and an experiment? Give examples. Observational study. Observing and measuring specific characteristics without attempting to modify or influence the individuals being studied. In an observational study, the researcher merely observes and tries to draw conclusions based on the observation. Here's an example. A study took a random sample of adults, asking them about their bedtime habits. The data showed that people who drank a glass of warm milk before bedtime were more likely to go to sleep earlier than those who didn't. Experiment. Apply some treatment and then observe its effect on the individuals. The individuals in experiments are called experimental units, and they are often called subjects when they are people. In other words, an experiment is a controlled study that aims to determine the effect of one or more independent variable or factor, or a dependent outcome response variable. That means the same thing. Any combination of the values of the factors is called a treatment. The researcher manipulates the independent or explanatory variable and tries to determine how the manipulation influences the dependent or outcome variable in an experimental study. And here's an example. Another study took a group of adults and randomly divided them into two groups. One group was told to drink warm milk every night for a week, while the other group was told not to drink warm milk that week. Researchers then compared when each group fell asleep. So I hope you can clearly see the difference between the two. Observation versus an experiment. Describe cross-sectional, retrospective, and prospective studies. Give examples. So cross-sectional. Data are observed, an observational study, measured and collected at one point in time. A cross-sectional study is like a snapshot of a particular group of people at a given point in time. It is used to describe what is happening at that time. Example, a medical study examining the frequency of cancer among a population of different geographical locations. By doing this, any differences among them can most likely be attributed to a geographical location differences rather than something that happened over time. Retrospective or case control study. Data are collected from the past by going back in time, data that already exist. Example. Researchers ask participants about their smoking habits over the past 20 years. Then they can analyze any possible correlation between their smoking habits and diseases such as lung cancer. Let's continue. Prospective or longitudinal or cohort study. Data are collected in the future from groups called cohorts, sharing common factors. Longitudinal studies look at a group of people over an extended period. A couple of examples. A medical study follows a cohort of middle-aged people who vary in terms of smoking habits to test the hypothesis that the 20-year incidence rate of lung cancer will be highest among heavy smokers, followed by moderate smokers, and then non-smokers. Example, the Framingham Heart Study began in 1948 and is a long-term ongoing cardiovascular cohort study of residents of the city of Framingham, Massachusetts. So that's an example of that. Another one called the Nurses' Health Study that started in 1976. It followed thousands of female nurses, asked them about diet and lifestyle, proved that trans fats hurt the heart, showed Mediterranean diets keep you healthy. Another one, the Millennium Cohort Study started in 2000, follows nearly 19,000 UK children, United Kingdom, tracks them from infancy into adulthood, looks at how home life affects schools, studies how screen time, and that's really the key nowadays, screen time changes mental health. So those are some examples. What is sampling error? Non-sampling error, non-random sampling error, and voluntary response sample. Sampling error. Sampling error is the difference between a sample result and the true population result. That is the consequence of chance sample variation, meaning you have a population versus a sample, not the same size. It could happen. So that's no. Non-sampling error. The non-sampling error occurs due to data that are incorrectly collected, recorded, or analyzed. It may happen by selecting a biased sample, using a defective instrument, or copying the data incorrectly. So we, in essence, we make a mistake. Non-random sampling error. Non-random sampling error is the result of using a sampling method that is not random, such as using convenient sample or a voluntary response. Randomness is extremely important. Voluntary response sample or self-selected survey. One in which the respondents themselves decide whether to be included. In this case, valid conclusion can be made only by the specific group of people who agree to participate. And by the way, sometimes we have no choice to send the survey, and those who decide to be a part of it, they will participate, others won't. So there is really no choice, but nevertheless, it does create some problems as far as the result is concerned. What are some characteristics of an experiment? Confounding. Confounding occurs in an experiment when the experimenter is not able to distinguish between the effects of different factors. Common confounders are characteristics of the participants, such as body mass index, smoking status, age at onset of illness, socioeconomic status, educational status, extent of support network, and life events. So the idea is that lung cancer is the outcome. Why is that? Is that because of smoking? Is that because of the alcohol use or exposure to alcohol use? Is it smoking or exposure to smoking? Somebody else was smoking on a regular basis near the patient. So there are some confounding, something that is hard to figure out. Blinding. Subject does not no, he or she is receiving a treatment or placebo. What's a placebo? A fake medical treatment. The placebo effect is when a person's physical or mental health appears to improve after taking a placebo or dummy treatment. Blocks, groups of subjects with similar characteristics are called blocks when it comes to an experiment. Completely randomized experimental design. Subjects are put into blocks through a process of random selection. You want to come up with, let's say, 4 blocks, and each block randomly you assign subjects to. Replication. Repetition of an experiment when there are enough subjects to recognize the differences in different treatment. That's extremely important if the resources allow that. Sample size refers to the number of individuals or items selected from the population to be included in a sample for a research study or statistical analysis. It must be large enough to display the true nature of the population data and should be obtained using the appropriate random method. Of course, again, depending on the limitation of resources available. Explain some misuses of statistics. Bad samples, small samples, misleading graphs, distorted percentages, loaded questions, order of questions, refusal to answer, correlation and causality, self-interest study, precise numbers, partial pictures. So there are a lot of ways to misuse statistics. We want to be aware of that. So having said that, pick the graph, double the length, width, and height of a cube, and a volume increases by a factor of 8 because 2 cubed is 8. To correctly interpret the graph, we should analyze the numerical information given in the graph instead of being misled by its general shape. So, okay, 10 versus 20, and this is 8 times larger as far as the volume is concerned. Deliberate distortion, loaded questions. Should the governor have the line item veto to eliminate waste? That's one way to ask. The answer is yes, 95%. Should the governor have the line item veto or not? We don't have this word-based 53%. You see a huge difference between the two. So that's possible, as you can see. Note, if sample data are not collected in an appropriate way, the data may be completely useless, that no amount of statistical training can salvage them. Randomness typically plays a critical role in determining which data to collect. A research center questioned 2,000 adults in the US to estimate the proportion of the population favoring death penalty for murderers. It was found that 70% are in favor of death penalty for murderers. State the individual, variable, population, sample, parameter, and statistics. So what is the population? We are dealing with all adults in the US. How many of them did we deal with? 2,000. That would be the sample. An individual would be one of those adults, one adult in the US. So what varies? What is the variable? You are for or against the death penalty, favoring death penalty for murderers. That's what varies, yes or no? For or against. Statistics. Well, it was found that 70% are in favor. 70% of what? Of those 2,000. So that is the 70% in favor of death penalty for murderers in this study would be considered statistical. Now, The perimeter, we don't have that. I want you to know that because perimeter refers to the population. In other words, what is the percentage of the people, the adults in the United States that are in favor? We don't have that. I want you to know that. End of this story. So it is unknown. However, in some texts, they may use the same 70% in favor of death penalty for murderers in the US as an approximation. Please understand, perimeter is missing. Okay? And normally it is missing in almost every study because we don't have access to the population. In most studies, that's why we pick a sample. Decide if each of the following describes an observational study or an experiment. The height of shoppers at the mall was recorded. It's just we're observing, observational study. A drug is given to a group of people and the reaction observed. So definitely it's an experiment. Okay. So we want to understand why it's an experiment, everybody. So the difference between an observational study and an experiment. Definitely there's a treatment involved, right? A drug is given to a group of people and the reaction involved. When the treatment is involved, that becomes an experiment. All right. A group of students are told to listen to music while taking a test, and the results are compared to a group not listening to music. Obviously, it's an experiment again. There's a treatment. In this case, the treatment is listening to music. The temperature on randomly selected days throughout the year were measured. We're just observing. The gender of children born in January were tallied. Again, observing, without a doubt, observation. The growth rate of bacteria is compared before and after adding alcohol. Definitely, it's an experiment because of the treatment that we are giving.